In today's lesson, we are going to talk about arithmetic sequences and series, and you will be able to find the first term and the common difference of an arithmetic sequence, solve problems involving the nth term of an arithmetic sequence, construct an arithmetic sequence given specific terms of the sequence, and find partial sums of an arithmetic series. A sequence in which a constant d can be added to each term to get the next term is called an arithmetic sequence. The constant d is called the common difference. In the first few examples, we'll have to find the first term and the common difference of the following sequences. So the first thing I'm going to say that the first term is represented a1, and in this case is 6. And to find the common difference, I am going to take 9 and subtract 6 and get 3 for the common difference. On the next problem, I'm going to say the first term is going to be 42, and the common difference will be 39 minus 42, which will give me negative 3. And on the last one, a1 is going to be 1, and the common difference will be 1 and 1/3, take away 1, which will give me 1/3 for the common difference. We can use the formula of an equals a1 plus n minus 1 times d to find an arithmetic sequence. So now let's see how that would look like on the next example, where we have to find the 21st term of an arithmetic sequence that has members of or terms of 4, 9, 14, and 19. So the first thing I'm going to find is my common difference. So my common difference will be 9 minus 4, which is 5. So I know that d is equal to 5. I also know a1 equals 4. So I am going to first write the rule for this arithmetic sequence, where an will equal to a1, which is 4, plus n minus 1 times the common difference, which is 5. So now I need to simplify. So an will equal to 4 plus 5n minus 5. Finally, an will equal to 5n minus 1. So this basically gives me the rule for this arithmetic sequence. Now all I have to do is find the 21st term. So I'm going to say a21 equals 5 times 21 minus 1. So a21 will equal to 105 minus 1. So a21 finally will equal to 104. In our next question, in this arithmetic sequence 2, 9, 16, and 23, which term has a value of 702? So the first thing I will do is construct a sequence. So I know that a1 is 2. I can find my common difference, which is 9 minus 2. So the common difference is going to equal to 7. So now I can write the general rule and say an equals 2 plus n minus 1 times 7. If I simplify, an equals 2 plus 7n minus 7. So the general rule is an equals 7n minus 5. Now I'm going to substitute 702 for an. So 702 will equal to 7n minus 5. So I'm going to add 5 to both sides and have 707 equals 7n. And if I divide by 7, I will get the nth term is going to be 101, or I can say the 101st term has a value of 702. In example number 6, the second term of an arithmetic sequence is 11 and the 10th term is 35. We need to construct a sequence. So the way we are going to do this is we are going to write two separate equations. So for the first one, I am going to say the second term is, the term value is 11. So 11 will equal, I don't know what the first term is, and I don't know what the common difference is, but I know that this is the value of the second term, so I can say 2 minus 1. So n equals 2 because this is the second term. So I'm going to say 11 equals a1 plus 2 minus 1 is 1, so a1 plus d. Now I'm going to use my next term, which is the 10th term, and that's going to give me 35. So I write a second equation, 35 equals the first term, which again I don't know, and I know that n is the 10 because it's the 10th term, so 10 minus 1, and again I don't know the common difference. So I have 35 equals a1 plus 9d. So now I have a system of equations in two variables, and my two variables are a1 and d. So I need to write them under each other. So I'm going to say 35 equals a1 plus 9d. And I am going to multiply the first equation by negative 1 and write it underneath. So negative 11 equals negative a1 minus d. So now if I add the two equations, I will get 24 equals 8d. And if I divide by 8, I will get the common difference, which is equal to 3. So now that I have the common difference, I can go back to one or the other original equation. So I'm going to go back to this first one right here and substitute in the common difference. So 11 equals a1 plus 3 is my common difference, and if I subtract 3, I will get a1 equals 8. So now that I have a1 equals 8 and common difference equals 3, I can write the rule for this sequence. an will equal to a1, which is 8, plus n minus 1 times 3, that's the common difference. So an will equal to 8 plus 3n minus 3, and in a simplified form, an will equal to 3n plus 5. So this is the general rule for this arithmetic sequence. An arithmetic mean of two numbers, a and b, is their average, where I am finding the sum of a and b and divided by 2. Therefore, if I have two terms in an arithmetic sequence that are a and b, a term in between the two, or the arithmetic mean, would be a plus b divided by 2, since a plus b divided by 2 is the midpoint between a and b. M1, M2, M3, and Mn are called arithmetic means between a and b if a1, m1, m2, m3, and so on to mn and b form an arithmetic sequence. So let's see how it works in an example. Insert three arithmetic means between 10 and 34. So I'm going to say that my first term is 10. Then I have to insert mean 1, mean 2, and mean 3. Therefore, my 34 is going to be my fifth term. So if the first term is 10 and the fifth term is 34, so I can write an equation where my fifth term, which is 34, will equal to the first term, which is 10, plus 5 minus 1 times d, because this is the fifth term. 34 is the fifth term, so n equals 5. So if I simplify, I get 34 equals 10 plus 4d. And if I solve for d, I get the common difference. So I'm going to subtract 10 from both sides and get 24 equals 4d. And if I divide by 4, d will equal to 6. Therefore, my first term is going to be 10. My second term is 16. My next term is 22. The next term is going to be 28. And the last term is 34. Every place or between every term, I can see that the common difference is going to be 6.